Now that we've learned what polynomials are and then how to add and subtract them, the next step is going to be multiplying them, you can imagine. So before we get into multiplying, let's remind ourselves of one rule that we learned from chapter 4, which is that b to the m times b to the n is b to the m plus n. I'm not sure why the word and was written in there, but that's good enough. All right, now we're going to find the product. So this problem right here is actually a review of what we already did in chapter 4. Matter of fact, both of these are, more or less. Okay, so let's remind ourselves. This is really the same thing as 4 times x cubed times y to the 5th times, I mean, there's no reason for the parentheses is what I'm getting at here, times negative 2x squared y. Okay, so that's equal to, let me line that, 4 times negative 2. That would be negative 8. Let me write it out. 4 times, oh my goodness, I can't type. All right, 4 times negative 2, and then we have x cubed, then we have an x squared, then we have a y to the 5th, and then we have a y. So that's negative 8, like I said, x to the, okay, but the rule says that you have to add these two powers. So that's going to be 5, y to the, now there's 5 here, and you don't see anything on this one, which must mean it's a 1, right? And 5 plus 1 makes 6. And there we go. Oops, I'm going to make it bold so it makes it a little bit more obvious on the page. All right, so we have negative 8x to the 5th, y to the 6th. Cool. All right, so now for this one, again, this is a little bit of review, sort of, but we are going to expand the idea here. All right, hold on, let me make it bold. There we go. All right, so now what we're going to do is we're going to distribute. Because there's this addition and subtraction in here, you're going to take 6x cubed and you're going to multiply it by each of these other terms. So 3x squared. Then you're going to subtract because of the minus for the 2. Or if you want to think of it, you can add a negative. But 6x cubed times 2x. And then you're going to minus, and then 6x cubed again, times 7. Okay, well, that's kind of a mess. So we don't have to think of it this messy all the time, but we're doing it this way this one time just so we can kind of see. So the first one is going to become 6 and 3. 6 times 3 is 18. And x to the 5th power, because you add these powers. 3 plus 2 makes 5. Then minus 12, because 6 times 2 is 12. X to the, not c, x to the 4th, because there's 3 here and 1 here. Remember, when you don't see a power, that's the 1 power. Minus 42 x to the 3rd. This one has a 0 power over here. That's 7. That's x to the 0 because there is no x, right? And 0 plus 3 is 3. And there we go. All done. All right, so the first one, this letter A, there was no distributing really necessary because it was just all multiplied. So that's a review problem from 4.1 actually. And a lot of students will say, hey, do I have to show all this work? Nah, for one this simple, probably not. You should check with your instructor, but you probably could get away with just kind of going from here right to the answer because, you know, 4 times 2 is 8. X cubed, x squared makes x to the 5th, and so on. Okay, but for your notes, you want to write down everything. That way you'll know how you got there. For the second one over on the right, it's you have to distribute because of that subtraction, right? So you have to do 6x cubed times each of those things. And when you're starting out, you might want to write it out. So, but when you get more used to it, you don't need to write out as much. But it's 6 times 3 makes 18, x to the 5th. And then 6 times negative 2 makes negative 12, and then x to the 4th, and so on. So most of the time, you're not going to bother with that intermediate step in between, right? But when you're writing your notes out, you want to write it out because that gives you a sense of what you were doing in the first place, right? It's all easy when I'm doing it. The problem is going back in 2 weeks and figuring out how you got those answers, right? Okay, so now we're going to kind of review. We're going to add, subtract, or multiply depending on what's required. So this is kind of a recap of last time and this time. So we'll start off with the first one. I have 9x plus 9x. Okay, so let me go down here. 9x plus 9x would be equal to 18x, right? If you have 9 of something plus 9 more of something, that gives you 18 of that something, right? You're combining like terms on this one because it's addition. All right, what about the next one? 9x times 9x. Well, that's not combining like terms, right? 9x times 9x would be 9 times 9, which is 81. And x times x is x squared. Sorry. Because you have one x and one more x, that makes x squared. You're adding the powers. Notice these two are very different, right? The one on the left, you're combining like terms. You leave the x just plain x. The one on the right, you're multiplying, so you're going to have to use this property up here where you add the powers. All right, next. What about these two for letter C? Well, you're in trouble because they are not like terms. If you're going to add two terms like this, they have to have the same letter, which they've got, both are x's, and the same power. And these two don't have the same power, so you're done. Well, what about D then? You might be thinking. Well, D is a different story because I'm not trying to add them, right? I'm trying to multiply them. In multiplication, I don't need them to be the same, right? Multiplying, you just multiply. So you say, let's see, 2x to the fourth times 8x to the third. You just multiply. You say, okay, 2 times 8 is 16. X to the, and then with these powers, you add them. 4 plus 3 makes 7. Done. All right, now what about E? Well, they're like terms again in E because you're trying to subtract them there. And that's okay because they're both plain x squared, right? So 3x squared minus 8x squared would be equal to negative 5x squared. Again, you just leave the x squared alone because, oopsie, there we go. You leave the x squared alone because adding and subtracting, you always leave the variable part alone. It's just the numbers that are getting changed. When you're multiplying, however, that's a different story. So if I'm going to multiply these two same terms, right, like this, then you're going to have to multiply the numbers and add the powers. So 3 times 8 is 24. X squared times x squared, you add the powers and become x to the fourth. There we go. Now for letter G, we're in a little bit of trouble because we're trying to subtract an x squared and a y squared. But those aren't the same variables, so we cannot simplify them. They're not like terms. We're done. Right? They are what they are. All right, now what about H? Well, H, it's okay that they're not the same. I don't need them to be the same. I'm just trying to multiply them, right? 7x squared times negative 7y squared. That would be equal to negative 49, because 7 times negative 7 is negative 49. X squared, y squared. You don't add the powers on this one because they're not the same variable, right? You add the powers when they're the same variable. Hold on. Which these ones aren't. So let me go back up to the rule here. So if you look at this rule, it's the same letter, b to the m, b to the n, then you can add the powers. When I did this one right here with the x to the fourth and x to the third, they were the same power, x to the fourth, x to the third, and the same base, x. So I'm able to add the powers. But for this one on h, I don't have to because it's x and y, so you just write them, x squared, y squared. Now notice what happened. In order to be able to add or subtract, they must be like terms. That's what happened with G and C. We couldn't do them because they weren't alike. They have to have the same variables and the same powers. G didn't have the same variables. C didn't have the same powers. But when you're multiplying, you don't care, right? You don't need like terms to multiply. You just multiply. Right? That's all that's required. You just have to remember this little rule that we learned in chapter 4. Now everything on this page was multiplying monomials, right? All of these over here on the right-hand column. I'm taking a single term times a single term and I'm multiplying them, right? So then the question becomes, how do you multiply them if they're not monomials? What do you do if they're binomials or trinomials or something like that? And that's what the next page is going to start us off on. So I'll begin this in this video and finish it in the next. So let's start with multiplying binomials. Now a binomial is when it has two terms. So if you look here, oops, I'm on the far right there. Come here. There it is. All right, there's a monomial, the x. There's another monomial, the 3. And when you string them together with an addition sign, that makes them a binomial because there's 2 of them, right? Same thing here. This is a binomial, okay? 2 terms. Okay, so we are going to multiply this sucker. Hold on one second. There we go. Okay, so I want x plus 3 times x plus 5. So what you're going to do is you're going to distribute, just like we were doing from the monomials, right? Here, let me bring them back up. When we distributed right up here with this one, right? So we distributed. We took 6x cubed times this one, and then 6x cubed times the next one, and 6x cubed times the third term, and so on. So I'm going to do that again, but I'm going to have to do it for both things. Oops, I'm sorry, I'm running out. There we go. All right, so I want to take this first term, x, and I'm going to multiply it by each of these 2. So you take x times x, and then plus x times 5. Right? So there's x times both of these 2. And now I'm going to do it again with 3. So plus 3 times x, that's this 3 right here, times this x right here. And then I'm going to take 3 times 5. So plus 3 times 5. Oops, 5. And then all we have to do is simplify, and everything will be great. X times x is x squared, plus a 5x plus a 3x, because standard notation is to write those with the numbers in front. And then those 2 can get combined. These 2 middle terms right here can get combined. So that's plus 8x plus 15. Now, there's a little mnemonic is what it's called, a way to remember what we're doing here. And it's called FOIL. So when you look at these 2, these were the first positions in both of those parentheses. So x times x was x squared. There it is. So the way to remember that is F. F for firsts, because it was the first position. And then x times 5 was the outer positions, right? Because x is on the outside and 5 is on the outside. So those 2 are on the outside, so that's O to help you remember it. And then these 2, the 3 and the x, are on the insides, right? 3 is here, x is here, so that's inners, and then, or insides. And then the 3 and the 5 are lasts, because they were the last positions in their respective parentheses. So F-O-I-L, FOIL. First, outers, inners, last. It's just a mnemonic device to help you to remember to distribute, right? And I'll be honest, I kind of use the word FOIL as distribute. I kind of use them interchangeably. Many math teachers in the world are now groaning at me. I know it's terrible, but it's just the way I remember what I'm trying to do. So we're trying to multiply things that have more than one term. When you're trying to multiply things that only have one term, that's chapter 4 stuff. That's right here, right? So that's when you add the powers or don't add the powers. It just depends on the problem. Oopsie, and so on. But FOIL, F-O-I-L, is the mnemonic way that we remember to multiply appropriately for 2 binomials. Technically, it only works for binomials. However, most students kind of use that word to mean distribute as well. Many math teachers don't like that. I understand. I know where you're coming from. All right, so with that, I think we will pause right there. We've gone over what FOIL is, and I will pick up next time on problem example 3, and we'll do all these FOIL problems together. See you then.